Hi fellas, this is Chemaddcts again to the solution. So welcome back once again to my another video tutorial. Well, guess what? Today we're gonna solve chemistry rate problems. Okay, so today this is the video tutorial for A2 students, advanced level student for advanced level student, not for advanced subsidiary student. I'm really sorry for that. Okay, so let's get started. So today's topic is how to identify reactants which will have constant concentration. Okay. So what we will do in this video tutorial? Well, we will discuss how to find the order of one reactant by ignoring the other reactants. Okay. What things we could learn from this video? We will learn about how to vary one reactant and keeping the other, how to vary the concentration of one reactant. This means the concentration of one reactant and keeping the other concentration of reactants constant. Okay. So let us at first look at the summary of this video. Here we will learn to solve a problem relating rates and order of a reaction, concentration of reactants, some useful definitions of this topic, some of the useful definitions of this topic, analyze the rate equation, how changing concentrations of reactant may affect the rate of the reaction, why we should take some reactants in excess and the other one limited. What is meant by a concentration of reactants are virtually what is meant by a concentration of reactants are virtually constant. Okay. How rate affects concentration time graph of a particular reactant, some important key points about this topic, some of the tips and tricks regarding this topic, okay, regarding this problem. So well fellas, now you can see that there are many points. So I I hope not the video tutorial wouldn't be longer. Okay, let us hope that the video tutorial will be shorter. Okay, so we're gonna learn all the basic concepts regarding this topic. Okay, all the possible basic concepts regarding this topic. Okay, so let's at first let us see the question. So let's get started. Okay, so at first let us see the question. So this is the study question for today. This is the study question for today. So let us at first read this question. Iodine and propanone react in the presence of an aqueous acid catalyst as follows. This is propanone reacting with iodine, giving us this iodopropane and hydrogen iodide. Okay. So to determine the rate equation for the reaction, propanone is reacted with iodine in the presence of aqueous hydrochloric acid at constant temperature. Samples are withdrawn at known times, quenched with sodium hydrogen carbonate solution. I'm making the mistake. Sodium hydrogen carbonate solution, and the iodine remaining and the remaining iodine is being titrated with a standard solution of sodium thiosulfate. Okay, so we are not bothered about this description. We will discuss in the later video tutorial. Okay, so this will be needed in the later question. Okay, we will not bother about these pieces of information. What we will bother here about the rate equation that is given here. Okay, so we will bother about the rate equation. This is the rate equation given for this reaction. So this is the rate equation. Okay, so let us see what does they asked. The graph of concentration of iodine. Okay, this is meant concentration of iodine against time is a straight line showing that the order of reaction with respect to iodine is 0. Okay, Explain why the propanol and the hydrogen ions must be in a large excess in this experiment in order to give this straight line. Okay. So before solving this question, let us look at some of the important definition for this problem. Okay. Let us get renowned by these terms. Okay. So first of all, we will represent concentration of reactant by this reactant in first what does this call third bracket. So we will represent concentration of reactant by this reactant in third bracket and product by product in third bracket. Okay. So this is the definition for rate of reaction. Rate of reaction simply means change with respect to time. So it is the change of concentration of reactants with respect to time. So we also know that rate is proportional to the initial concentration of reactants raised to appropriate powers. Okay. So what does this appropriate powers means? So appropriate power here, order of reaction is equal to raised to appropriate powers. Okay. Here the appropriate powers simply means order of reaction. So what does the term rate determining step means, or RDS? Okay. RDS. So RDS simply means a reaction may involve many steps. Rate determining step, or RDS, is the slowest step in the multi-step mechanism. If a reaction involves multi-step mechanism, so the slowest step is the rate determining step. Okay, I hope that you have understood. So if not, please let me know in the comment section. Okay, I'm happy to help you out. Order of the reaction. It is number of particles involved up to and including RDS, or rate determining step. Okay, so it is the number of particles involved. Okay, up to and including RDS, rate determining step. So the particles here means the reactants, the particles of the reactants. Okay, so obviously the reactants will react and form products. So here we will only concerned about the reactants. Okay. So this is the particles for reactants. So I hope that you have understood the definitions. Okay. So if not, let me know in the comment section. So let us get back into the topic. Okay. So now let us examine this question. Okay. At first, let us examine this question. Okay. So in here, what is happening? Here we have taken iodine and propanol to react together. Okay. So here we have also given H plus as catalyst. Okay. So why am I repeating okay several times? Sorry. So okay. Sorry. Um, where were we? Yeah. So what should I say first? Okay. Here in A it says the graph of I2 against time is a straight line. Okay. Uh, the graph of I2 against time is a straight line, showing that the order of reaction with respect to iodine is 0. So by this meantime we have known that the order of iodine is 0. Here, since it is 0, so obviously the order of iodine would be 0. So let us see what does this question asked. Explain why the propanol and the hydrogen ions must be in large excess in this experiment in order to give a straight line. So what were we are doing? We are in fact taking hydrogen ions and propanol ions in large excess, and now let us see So which are in excess and which are in limited. Okay, so which are in excess? In here, propanone is excess and H plus is excess. It is given in the question. Okay, the information is given in the question. So but in here, iodine that is given here is limited. How we are supposed to say that this iodine is limited? Because they have already said that they have already mentioned these two as large excess. So obviously iodine must be limited. So as you know that in a reaction, one reactant should be limited and another reactant should be in excess. So by that concept we have came to know that iodine should be limited. Okay. Ahaha. So now let us see that why we have taken taking these two things in large excess. So since we have taken this in large excess, that means it has excess means higher concentration. That means their concentration is very high concentration. That means their concentration is very high. So their change in concentration with respect to time will be negligible. Okay, change in concentration with respect to time would be negligible. Okay, so the change in time, therefore the change in concentration with respect to time would be negligible, since they have very high concentration, very high concentration. So their change in concentration with respect to time would be negligible. That means the concentration of these two things, that is propanone and H plus, concentration of propanone and H plus is constant concentration. These two species have constant concentration. Okay, so from this rate equation we can say that these two things is in constant. That means the concentration of this and this are constant. So the only thing we have left here is iodine. So here the concentration of iodine is variable since it is in limited. So the concentration of iodine with respect to time would be variable. Okay, so since it is in limited amount, so small change would cause greater impact. Okay, so small change in iodine would cause a greater impact. Since this propanone and H plus are in large excess, a small change would have no effect or impact on this concentration. So I hope that you have understood. If not, please let me know in the comment section. So iodine, concentration of iodine here is variable. Concentration of iodine is variable. Concentration of iodine here is variable. So by this meantime we can say that propanone and hydrogen ions have constant concentration. So why we are taking these two concentration as constant? That's because we are here determining the order of iodine from the experiment. So here we are interested to find the order of iodine in this reaction. So that is why we are taking these two concentration as constant and we are varying this concentration. And by varying this concentration we will also see how this affects the rate. So I hope that you have got the answer. You have got the point. Okay. We are not still going to the answer. So be there with me. Please don't go away. Okay. Since we are discussing in detail, so the video tutorial might get a little bit longer. Okay. So stay tuned. So here now we have known that which concentration is constant and which concentration should be variable. Okay. So now let us see what is meant by. Okay, so let us now discuss the. Now let us come back to the answer. Okay, so now let us discuss the answer. So what should be the answer? Explain why the propanol and hydrogen must be in large excess in this experiment in order to give this straight line. Okay, so why we have taken this in large excess? So that, so to ensure. Okay, so at first let us discuss why we have taken propanol and hydrogen ions in large excess. Well, the first thing is that to ensure that concentration of hydrogen ion and concentration of propanol are virtually constant, so that overall order is not determined. So what order we are determining here is particularly for iodine. Okay, so we are determining the order of iodine only. So that is why we are taking this thing constant and we are not determining the overall order. So H plus and propanol, so that the concentration of H plus and the concentration of propanol are virtually constant. Well, now let us look at what is meant by virtually constant. Virtually constant means it is close to constant. Okay, it is close to constant, but it is not constant. There might be a slightly change in the concentration, but those are negligible. That is negligible change. There is a negligible change. When there is a negligible change, we say that the the thing is virtually constant. So in here, the change in concentration of these two guys are negligible. So they are virtually constant. So that is why they are virtually constant. And another important thing to say that here we are changing the concentration of iodine, not the concentration of hydrogen ion and propanol ion. Since we are calculating the order of reaction of iodine. Okay.